Hi everyone, I'm Sunja, Microsoft MVP. Today I would like to share with you about configure security for data infrastructure. This is the video number 15 about uh, about Azure Security Center Series. Video number 15. Okay, who am I? I'm Sunja. You can find me at my Twitter. If you got any question, you can find more Azure Security Center hands-on lab at techconnect.io. Okay, let's get started with today's topic. Configure an SQL database firewall. Azure SQL Database and Azure SQL Data Warehouse provide a relational database service for Azure and other internet-based applications to help protect data. Firewall prevent all access to your database server until customer explicitly specify which computer have permission. The firewall grants access to database based on the originating IP address for each request. In addition to IP rules, the firewall also manages virtual network rules. Virtual network rules are based on virtual network service endpoint. In order to selectively grant access to just one of the database hosted the same Azure SQL database server, it is necessary to create a database level rules for the required database. This involves specifying an IP address range for the database IP firewall rules that is beyond the IP address range specified in the server level IP firewall rules, and ensuring that the IP address of the client falls in the range specified in database level rules. SQL Data Warehouse only supports server-level IP firewall rules and not database-level IP firewall rules. Note that to allow application from Azure to connect to your Azure SQL database, Azure connection must be enabled. When an application from Azure attempts to connect to your database server, the firewall verifies that Azure connections are allowed. Emphasize that database-level IP firewall rules enable clients to access certain secure database within the same SQL database server. However, such rules need to be created by using transact SQL statement after server level firewall have been configured. Enable database on authentication and authorization. SQL database support two types of authentication. SQL authentication use username and password. When creating SQL database server, it is necessary to specify a server admin login with a username and password. This credential can be used to authenticate to any database on that server and as database owner. Azure Active Directory authentication is identified managed by Azure AD and is supported for managed and integrated domain. In order to use Azure AD authentication, it is necessary to create another server admin called Azure AD admin. This admin is allowed to administer Azure AD user and group, in addition to performing all operations that a regular server admin can. Regardless of the authentication method, you can create two types of database user. More specifically, you can create a user account in the master database and grant permission in all databases on the server, or you can create them in the database itself. The latter represent so-called content database user. By using database content user, you enhance database portability. Azure Cosmos DB does not facilitate user-based authentication, but instead use hash-matched authentication code for authorization. Each request is hashed using the secret account key, and the subsequent base 64 encoded hash is sent with each call to Cosmos DB. To validate the request, the Cosmos DB service use the correct key and property to generate a hash. It then compares the value with the one in the request. If the two values match, the operation is authorized and the request is processed. If the value non match, an authorization failure occurs and the request is rejected. Customer can use either a master key or resource token to allow fine grained access to a resource such as a document. Using the master key, it is possible to create user resources and permission resources per database. A resource token is associated with a permission in a database. It determines whether the user has access, read, write, read-only, or no access to an application resources in the database, such as container, document, attachment, store procedure, trigger, and user-defined function. That the resources token is then used during authentication to provide or deny access to the resources. Okay, here we have some exercise to enable Azure AD authentication for SQL database. You can try it by yourself. This is the first exercise. Okay, let's go for the next topic. Enable database enable database auditing. You can use SQL database auditing to return an audit trail to selected event, including finding categories of database action to be audited, report, and database activity. Using pre-configured report and a dashboard to get started quickly with activity and event reporting. An analyze report that help identifying suspicious events with unusual activity and churn. You can define auditing policy for a specific database or as a default server policy. A server policy applies to all existing and newly created databases and on the server. If server block auditing is enabled, it always applies to the database. The database will be audited regardless of the database auditing setting, enabling block auditing on the database or data warehouse. In addition to enabling it on the server, does not override or change any of the settings of the server block auditing. Both audits will exist side by side. As best practice, avoid enabling both server block auditing and database block auditing together, unless you want to use a different storage account or retention period for specific database, or unless you want to audit event type or category for a specific database that different from the rest of the database on the server. For example, you might have table insert that need to be audited but only for a specific database. You need to use Azure PowerShell or REST API to customize audited event. Let's go for the topic of configure SQL database threat protection. Threat detection provides a new layer of security that enables customers to detect and respond to potential threats as they occur. By providing security alert on anomalous activities, users receive an alert for sufficient database activity, potential vulnerability, SQL injection attack, and anomalous database access and query pattern. That detection integrates alert with Azure Security Center, which include details of suspicious activity and provide recognition regarding investigating and mitigating the threat. Threat detection makes it simple to address potential threats to the database without the need to be security expert manage advanced security monitoring system. Threat detection is part of advanced data security offering, which is unified package for advanced advanced SQL security capability. Threat detection can be accessed and managed via the Central SQL Advanced Data Security Portal. Advanced Data Security provides a set of advanced SQL capability, including data discovery and classification, vulnerability assessment, and threat detection. Data discovery and classification provide capability built into Azure SQL database for discovering, classifying, labeling, and protecting the sensitivity data in your database. You can use it to provide visibility into your database, classification state, and to track access to sensitivity data within the database and beyond its border. Vulnerability assessment is an easy-to-configure service that can discover, track, and help you remediate potential database vulnerability. It provides visibility into your security state and includes actionable steps to resolve security issues and enhance your database fortification. Threat detection detects unusual anomalous activity indicating potentially harmful attempts to access or exploit your database. It continually monitors your database for suspicious activity and provides immediate security alert on potential vulnerabilities, SQL injection, and anomalous database access pattern. Threat detection alert provides details of the suspicious activity and recommend action on how to investigate and mitigate the threat. You only need to turn on SQL Advanced Data Security once to enable all of these included features for all databases on your SQL database server or managed instance. Enabling or managing advanced data security settings require belonging to the SQL Security Manager role, SQL Database Admin role, or SQL Server Admin role. Configure access control for storage account. Every request made against a secure resources in a block, file, queue, or table service must be authorized. Authorization ensures that resources in your storage account are accessible only when you want them to be, and only to those users or applications to whom you grant access. You can authorize requests for Azure storage by using Azure AD SSE and Share Access Signature. You also have the option enabling anonymous access. Azure AD is the Microsoft Cloud-based identity and access management service. Azure AD integration is currently available in preview for the block and queue services. With Azure AD, you can assign fine-grained access to user group or application via RBAC. For more information about Azure AD integration with Azure Storage, you can find it and automate it with Azure Active Directory. Access key provides full permission to the storage account, including the ability to delete. Share key authorization relies on your account access key and other parameters to produce an encrypted signature string that is passed on via the request in the authorization header. For more information about share key authentication, see authorization with share key. Share access signature. A share access signature (SNS) delegate access to a particular resources in your account with specified permission and over a specified time interval. For more information about SNS, see delegating access with a share access signature. Anonymous access to container and block. You can optionally make block resources public at the container or block level. A public container or block are accessible to any user for anonymous access. Read requests to public container and block do not require authorization. For more information, you can see Manage Anonymous Read Access to Container and Block. Okay, here we have some exercise. The second exercise for configure key management for storage account. Let's come to topic create and manage SAS. SAS provide dedicated access to resources in your storage account. With an SAS, you can grant client access to resources in your storage account without sharing your account key, which is the key point of using SAS in your application. SAS is a secure way to share your storage resources without compromising your account key. SAS gives you a granular control over the type of access you grant to clients who have the SAS, including the interval over which the SAS is ready, including the start time and expiry time. The permission granted by the SAS, for example, an SAS for a block might grant read and write permission to debug, but not delete permission. An optional IP address or range of IP address from which Azure Storage will accept the SAS. For example, you might specify a range of IP address belonging to your organization. The protocol over which Azure Storage will accept SAS. You can use this optional parameter restrict access to client using as HTTP. You can create two types of SAS. Service SAS. The service SAS delegates access to our resources in just one of the storage service block queue tables or file service. Account SAS. The account SAS delegates access to resources in one or more of the storage service. All of the operations available via service SAS are also available via an account SAS. Additionally, with the account SAS, you can delegate access to operations that apply to a given service, such as get or set, service property, and get service state. You can also delegate access to read, write, and delete operations on block, container, table, queue, and file share that are not permitted with a service SAS. Two common design patterns where an SAS is useful is a service where users read and write their own data to your storage account. Independent client upload and download data via a front-end proxy service that performs authentication. This front-end proxy service has the advantage of allowing validation of business rules. But for large amounts of data or high volume transaction, creating a service that can scale to match demand could be expensive or difficult. In the second pattern, a lightweight service authenticates the client as needed and then generate an SAS. After the client receives the SAS, they can access storage account resources directly using the permission defined by the SAS and the interval allowed by the SAS. The SAS mitigates the need for routing all data through the front-end process service. Note that many real-world services use a hybrid of these two approaches. For example, some data might be processed and validate via the front-end process, while other data is saved and read or just read directly using SAS. Let's come to topic of configure Azure Security for Azure HD Insight. HD Insight security model consists of four major pillars: perimeter, security, authentication, authorization, and encryption. You can achieve stronger perimeter security in HD Insight through virtual network and the Azure VPN gateway service. An enterprise admin can create an enterprise security package cluster inside a virtual network and use network security group to restrict access to the virtual network. Only the IP address defined in the inbound firewalls will be able to communicate with the HDInside cluster. This configuration provides perimeter security. Another layer of perimeter security is archived through the VPN gateway service. The gateway acts as first line of defender for any incoming request to the HDInside cluster. It accesses the request validate and only then allow the request to pass the other node in cluster. In this way, the VPN gateway service provides perimeter security to other name and data node in the cluster. An enterprise admin can create an HDInside cluster with enterprise security package in a virtual node. All the nodes of the HDInside cluster are joined to the domain that the enterprise manages. This is achieved through the use of Azure Active Directory domain services with this setup. Enterprise employees can sign in to the cluster node by using their domain credential. They can use their domain credential to authenticate and interact with the cluster via other approved endpoints such as Apache, Review, Microsoft Open Database Connectivity, Java Database Connectivity, PowerShell, and REST API. In regards to authorization, the admin can define a BAC policy for the cluster resources. For example, the admin can configure Apache ranges to set access control policy for Hive. The functionality ensures that employees can access only as much data as they need to be successful in their job. Access trace access to the cluster is also restricted to only the administrator. Most data stored for HDInside cluster, Azure Blob Storage and Azure Data Lake Storage Gen 1 or Gen 2 support transparent server-side encryption of data at rest. Secure HDInside cluster will seamlessly work with this server-side encryption capability of data at rest. Let's come to our topic: configure security for Cosmos DB. The first layer of Azure provides physical safety of data center and continuous protection from distributed denial of service attack (DDoS). Azure has dedicated teams that continuously monitor security issues. All Azure services run a common security agent to collect anomalous security activity. Production resources are patched regularly and all secret certificates and passwords have a defined lifetime. This secret and certificate should be rotated after they expire. All production ports in Cosmos DB are scanned and penetration tested regularly. Each source code is scanned for security issues and prepared to approve before integrating into product. IP firewall is the next layer of protection to secure your database. Cosmos DB supports policy-driven IP-based access control for inbound firewall support. This model is similar to the firewalls of a traditional database system and provides additional level of security to the Cosmos DB account. With this model, you can configure a Cosmos DB account to be accessible only from an approved set of machines and cloud service. Access to Cosmos DB resources from this approved set of machines and service still require the caller to present a valid authorization token. Virtual network is the next layer that secures Cosmos DB account. You can configure your customer DB account to allow access only from a specific subnet of Azure Virtual Network by enabling a service endpoint for customer DB from a virtual network and its subnet. Traffic is provided with an optional, optimal, and secure route to customer DB. After a customer DB account is configured with a virtual network service endpoint, it can be accessed only from this specific subnet, and the public or internet access is removed. You can filter network traffic to and from Azure resources in Azure Virtual Network with a network security group. A network security group contains security rules that allow or deny both inbound and outbound network traffic from several types of Azure resources. All access to a customer DB is controlled by two keys, a master key and read-only key. Master key, as its name implies, is a master key and can do all the operations on customer DB. A read-only key enables you to read the data, but no other actions are possible with this key. Okay, let's go for our last topic in this video 15. Configure security for Azure Data Lake. Azure Data Lake Storage Gen 2 is the result of covering the capability of our two existing storage services, Azure Blob Storage and Azure Data Lake Storage Gen 1. Features from Azure Data Lake Storage Gen 1, such as file system semantic, directory, and file level security and scale, are combined with low-cost tier storage and high-availability disaster recovery capability from Azure Blob Storage. A fundamental part of Data Lake Storage Gen 2 is the addition of hierarchical namespace to blob storage. The hierarchical namespace organizes object file in object or file into a hierarchy of directory for efficient data access. The security model for Data Lake Gen 2 supports ACL and portable operating system interface for unique permission, along with some extra granularity specific to Data Lake Storage Gen 2. You configure settings through Storage Explorer or through frameworks like Hive and Spark. This model offers a number of security features. In particular, all data writing to Azure storage is automatically encrypted using storage service encryption. Azure AD and RBAC are supported for Azure storage for both resources and management operation and data operation. For example, you can assign RBAC role scope to the storage account to security principal and use Azure AD to authorize resources management operations such as key management. Azure AD integration is supported for data operation on Azure storage. You can assign RBAC role scope to a subscription, resources group storage account, or an individual file system to a security principal or a managed identity for Azure resources. You can also run delegated access to the data object Azure storage using SIF. When considering configuration of the Azure Data Lake security, you can approach it by reviewing management and data plan individually. The management plan consists of operations that affect the storage account itself. For example, you can create or delete a storage account, get a list or storage account in a subscription, retrieve the storage account key, or generate the storage account key. Use the resources manager model of deployment, which is means for creating storage account with Data Lake Storage Gen 2 capability. With the resource manager storage account, rather than giving access to the entire subscription, you can control access on a more finite level to the management plan using RBAC. Data plane security refers to the methods used to secure the data objects stored in Azure storage. The recommendation is to use Azure AD instead where possible. For production application or for authorization access to Azure table and file, continue using share key while Azure AD integration is still in preview. Use SAS to grant control permission to specific data object for a specific amount of time. In addition to limiting access through authorization, you can also use firewall and virtual network to limit access to the storage account based on the network rules. This approach enables you to deny access to public internet traffic and to grant access only specific Azure virtual network or public internet IP address range. That's all for video 15 of Azure Security Center Series. If you got any question, you can take me at my Twitter. You can find today's video blog at dev.to/Jackson. That's all for today. Thank you.